This is the Docker revision video. In this video, we will see first the virtual machine and Docker difference. Then we will be going to see architecture of a Docker. And in this README file, it contains first the Docker revision. We will see some basic concepts over here, like image, containers, and Docker file etc. Then we have the CMD. In the CMD, here you can see we will see some basic all commands and then also implementation of these commands. Like here, it is Docker build is here in the main command. Here we I think we have I have mentioned here somewhere. So after that, it is the some other parts we have to give metadata for this command as well. So we will see all of these things here. I have added the sample code as well. I mean commands. Then after CMD, we will see Docker file for Spring Boot as well as the React app, how to build and what it contains. Then we have the Docker Compose. Docker Compose is nothing but we use it for to run the multiple containers. So yeah, it contains okay by using the .yml file, and in the YML file we have the top level keys, and in the top level key we also have the service level key. In the service level key we have a lot of another keys like you know actually, it is the containers kit. So we will see all of these things. After that, we have the networks and volumes. And then in the fifth, we have the YML basics. I have added it because we used to do a lot. I mean, we make a lot of grammatical mistakes. Sorry, mistakes in YML. Okay, not grammatical. Then we have the Docker workflow. So I will explain step by step what happens after the steps and what in the YML. So I will explain all over it. Then I have also added the dictionary. So in the virtual machine and Docker, here this is the virtual machine. Earlier in the when there was another Docker, we used to share this full OS. I mean virtual machine, or you can say that OS. To if you want to share an application, let's suppose we have the app A. So I want to share with the testing team. So what I used to do, I will share full OS to them, and then testing team will, after receiving the full OS, they will run this this OS, full OS on the virtual machine, like on the hypervisor, and we have this virtual machine on this virtual machine. They will run this full OS. So this is very not, I mean hard, or you can say that not feasible task, as we have to share full OS. It may be huge. I mean it is bulky, literally bulky. So it is not feasible. As well as there, you might get a lot of problems like I mean. Might be 32 bit, 64 bits. You may have Linux, you may have Windows. So it's too irritating, right? So that's why we come with the solution. Uh, we will not install the OS. We have only one OS. Okay. It is here. It's missing. We have the host operating system. Here also we have the host operating system. Like currently you are using a Windows. This is host operating system. It is the main OS, right? Uh, so on the top of this OS, like currently I am using the Windows, I will install the Docker software. Okay, why we will use the Docker software? Because it helps us to run these containers like app A, app B, app C. So these are all are the containers. So in that container, there are images, app A, app B. So why we use the containers? Because it also provides the host level security, or you can say that function level security, something like that. So we will see all of these things, but just remember these are the containers, and we run these containers on the top of Docker, and Docker is just a software installed on the OS. That's it. But here in the terms of virtual machine, we have the host operating system, then we have the hypervisor, and on the hypervisor we used to run whole OS, virtual machine. So that's not feasible. So that's the main difference between the Docker and a normal virtual machines. So let's see the Docker architecture. In the Docker architecture, there are three main components: Docker client, Docker host, and Docker registry. Remember, Docker client, Docker host, and Docker registry. In the Docker client, actually, let's first talk about Docker host. It contains, okay, Docker host is nothing but the application, and it's an engine in which we used to run the containers and store the images. Okay, uh, but To communicate with the Docker host, we should have something, right? So here it comes daemon. So daemon is the component in the Docker host which will help us to communicate with the Docker host. How? So here you can see the Docker client is nothing but the normal Windows CMD, or we can say that any command line. So from that we used to give the Docker build, Docker pull, Docker run. These are the commands. So for performing this command, we should have something, we can do directly Docker build, or you can say that Docker run, or container name. After that, what will happen? This command will go to the daemon. Okay, this command will go to the daemon, and daemon will handle this command, like where what should have to do with that command, what is the command, what action should have to perform. So all of this will be handled by the daemon. So the work of the daemon here, it is to communicate between the Docker host and the Docker client, right? Client might be a CLI or anything, or UI might be. Okay, so this is the main difference between that. So what is the containers and images? I hope you will know that. I will not be going to explain it, but still, okay, let's see. First, image is just nothing but a wrapper around the application. We used to give all the metadata of the application, or environment, you know, just like it needs this, it needs this. So I will give all the metadata of the application are required for the application to run. And after that, we have the containers. So in the one container, only one image can run. So remember, always remember this, and we can run multiple containers and we can communicate with them. Just like here, first container, it might contain the MySQL, and in another container, it might contain the Spring Boot. So so by using the Docker Compose, we can communicate with these two containers as well. Okay, so this is very helpful because we don't have to share whole you can say that virtual machine. You have to just share this images. Actually, you don't even need two containers, because containers can be recreated, images cannot, may not be if you delete whole. Okay, so then we have the Docker registry. In the Docker registry, you have a lot of options, like we have the Docker hub. This is the Docker's registry, just like GitHub. You have the Docker Hub. You also have the Amazon's ECS, I think. I don't know what is the full form. I think Elastic, something like that. So you can store your Docker images there also. So it it is used to do the CI/CD pipelines. Okay. So this is the architecture. Now I will go down just as I explained. Docker is a containerization platform. Okay, remember this. Docker is a containerization platform. Then containers share the host OS kernel. Okay, share the host OS kernel. It contains only one OS kernel, and on the top of that, we install the Docker. Then we have perfect for CI/CD pipelines. As I said, we do need the Docker registry as well as the Docker. Then great for full stack apps like Spring Boot, React plus TV. Then why we use the Docker? Because it gives the consistency, you know it does not give you a problem or errors. It has a portability because we will not share the full OS. We have to just share the images by using the Docker Hub, or we can share that Docker registry. Then it is a lightweight, as I said, because it does not contain any OS or any kind of extra things. Then isolation. It also gives the isolation, container level isolation. I don't know. It is OS level. No, it does not give the OS level isolation, but method level isolation or something like that. But it gives. Then we have the image. Here, some of the concepts you should know in the Docker. First, image. It is a blueprint template for your application. So it is nothing but the metadata which you will give to run your application, like which OS do you want to run this image. Like we have the Spring Boot app, so we will give the image, Docker. We will create the Docker file. It's nothing but to metadata for creating the image. Okay, in the Docker file, we will give which OS we want to run on this application. Run this application on, and many things there. Okay, port number and many more. So then we have the containers. It's nothing but the running instance of an image. So one container contains only one image. Always remember. Then Docker file, it's nothing but to use to build an image. Then registry, store images and versions. Like we have the Docker Hub, AWS, ECR, and GCR. Then we have the Docker Compose. It's uh, background service that runs containers and images. Okay, multiple containers. So here it is just for development purpose. I mean, testing purpose. We will not be using this at production level because we have the Kubernetes. Kubernetes also do the same task, but in advanced level. Docker Compose does not have. I'm saying in. I mean, advanced uh, things. That's why we don't use that. So after that, we have the daemon. As I said, it is responsible for to communicate between the Docker client and the Docker host. After that, we have the CMD. So these are the CMD commands. I will be going to revise it fastly. So Docker PS list list containers, then Docker PS minus a list all running. List all running as well as stopped containers. Docker images, Docker version, Docker run, uh, so Docker run, Docker stop, Docker start, Docker restart, and Docker rm. So these are the commands for container to run the container, stop the container, start the container, restart the container to remove the container. So before removing, we have to stop the container first, okay? And after these commands, we have to give the container ID. Okay, we can see the container ID by using the Docker ps minus a or Docker ps if it is run. Then we have the Docker RMI, Docker pull, push, build. So these are the commands we use to create the image, to pull or push the image, or to remove the image. Also, we have the Docker execute minus IT. It will create the and run the Docker as container for image. So yeah, then Docker logs, then Docker inspect. Docker logs and inspects are very important commands for container. Then Docker compose up, Docker compose down, Docker compose PS, Docker compose logs, Docker compose ls, Docker compose network inspect. Sorry, Docker network inspect. So actually, first this Docker compose, there are four commands that Docker compose mainly. Docker compose up, it will run all the containers. Docker compose down, it will stop and remove all the containers. Docker compose ps, it will list all the running containers. Docker compose logs, yeah, that's it gives the information of the containers. Then we have the Docker network ls, network inspect, then Docker volume ls, then Docker volume inspects. I don't think I have to explain this. Then we have the Docker kill, Docker top, Docker stats, and Docker info. I don't know what it is, but it will stop the Docker, I think. Docker engine. Then Docker login, Docker logout, Docker tag, Docker rename, Docker CP, Docker attach, Docker prune, Docker system df. So the important command here it is the Docker system prune minus here or something like that. So it will erase all the data, all the containers and images in your local system. So you should have to use it carefully. Okay, but I use it most of the time after doing the task. So Docker image prune and a lot of things are there already. So these are the commands which we have performed that time. Okay, what's the time? I don't know. So first, let's build. Let's suppose we have the image, quiz image, and its tag is this. Version is this. So Docker build minus t stands for this tag. We have, if we want to use the tag, you have to mention this my hyphen t. So Docker build hyphen t quiz image is to 0.0.2. Then after creating the image, we have to run that image in the container. Docker run hyphen name. Okay, quiz MySQL container. Then minus p stands for port. Then hyphen e and hyphen e. So it's nothing but the environmental variables we can give it. Okay. Then we have the MySQL 8.0. So I have run this SQL, okay, from the MySQL image. It's already built in, or if it is not in your local system, it will fetch from the Docker Hub. Okay. Now it's time to run this quiz image. Docker run hyphen name which container, port number is this. So first port, okay, minus p, and first port stands for your local port, and you want to bind with the this containers port. Okay. Remember, first one is host and second one is container. So you have to bind the ports. Okay, it's called a port binding. Remember, always remember this. And then we have to give the environmental variables again. So we have to give the DB URL. So I will give like this minus e, I mean hyphen e, like this, and then we have to mention the image name. That's it. Then we have the network. Why we require here the network? Because we have to start the conversation, I mean communication between this container, quiz MySQL, MySQL container, and this quiz container. Otherwise, how they can communicate? Because they have a security concern. One container cannot communicate with other container without permission. So we have to create the network for that. So we will create Docker network, create QuizNet, and then Docker network connect QuizNet. Remember QuizNet with quiz app container. So how the command looks like: Docker network connect quiznet quiznet quiz app container, like this. Then we have to also add quiznet for quiz MySQL container as well. So Docker network connect quiznet quiz MySQL. Okay. So Docker network connect. After that, you have to mention the network name and then container name. So it will add to that network. It's nothing but so QuizNet is nothing but the network we have created here. Like let's suppose here it is goal, or I mean circle, and in that circle you have to add just one by one container so that they can communicate with each other in this network like this. Then after that we have the Docker file. So we have came so far. Now we will see how Docker file we can make for the Spring Boot project. So first we have to select the image. Okay. So we will select from Eclipse. So this is the lightweight JDK image. You can check it here. So we have to mention the image name first from, then we have to set the working directory work dir slash app, then copy the jar file into container, copy target slash star all jar, know, whatever the jar contained in the target you have to copy in the as a app.jar, because we already have set the working directory. It will copy this jar file to this working directory. Then we have to export the port 8080 of that container. Okay, without exposing it cannot expose, we cannot access that port. Then we have to give the entry point. It is nothing but the commands which we will be going to actually perform in that container. Why? Because we have to run this image, right? App.jar. So java minus jar app.jar, that's it. So whatever, if you want to perform the commands, to run the application, you have to give in the array format and string and array formats. So entry point, and then you have to give the array of strings, and you have to specify one by one word of that command. Then for React, it is this. You have to again select build the React app. You have to get the node this image. From this image, set the working directory, copy the copy all this package dot star dot JSON to this working directory, and after that we have to run npm install. First we have to run npm install. Okay, it will run the image npm install, I think. Then copy again npm run build. Okay, after okay, run npm install, so it will install all the dependencies. Then it will create it will build the app, and we have to copy this app to container. Then from again Nignis Nignis Alpine. So this is the lightweight Nignis. Then we have to copy again this thing, and then we have to export 80 and cmd command. We have to perform this. I hope I haven't done this. I haven't run the React app, so I can't explain in detail here. So let's go for Docker Compose. So do you know in the Docker Compose why we use the Docker Compose? Because to run the multiple containers, we have also an alternate called as Kubernetes. You know, again, uh, remember this Docker Compose, we use it for to run the multiple containers. It helps us to run the multiple containers. We cannot run one by one container. Instead, we can give the one YML file, and by using that YML file, we can run all the containers and for all the images. Just like in the microservices, you cannot run one by one. I mean, you can run, but it's too irritating, right? So what we can do, we can give this YML, we can do this YML file uh, in the root folder, and for each microservices we can add the Docker file. Okay, without Docker file we cannot create the Docker Compose file. So here we have the top level kits like version. I think in the new Docker Compose version we don't have to even mention this version. Okay, you can remove successfully. So these are the top level keys: services, volumes, and networks. So the important keys are services, volumes, and networks. But the most important keys in the services, service level keys are this: image. You have to mention the image name. Then you can create the image as well from the Docker file. Then container name, ports, environment, depends on. It's actually, it will wait for to start the container. If it depends on another container like Spring Boot app, it dependent on the MySQL, so it will first wait for to start the MySQL. Then volumes, then networks, we can mention the volumes and networks with their respective keys. Then command and restart, there are a lot of values are there. Then health check. So in the networks and volumes, networks only driver is important, bridge for local, so there are some concepts there over there. Volumes, only the volumes name is needed, and driver can be default. So optional advanced kits, APM, IAM, and driver ops and external. So we'll be not going to see that. Okay. So let's assume two microservices, cab driver for location and cab user. So I have also added there. So MySQL, cab driver, and cab user. Okay, remember this. Then we have the MySQL database and Kafka with Zookeeper. So we'll be going to build Docker Compose for all of these images. Okay, so it has also separate image. It has also separate image, and MySQL has already separate image, and Kafka is also has a separate image. So we want to run all containers for all of these images and connect them as well by using one network. So first we will decide the version. Okay. Okay. Remember this, whenever you will want to give the value in the YML file and it contains some character, you can give it in the string format. Otherwise, you cannot, you can avoid the string. Also, you can give here the string format as well. Okay. So let's see. First, services, cab driver microservices. We want to run the cab driver microservices. So what we can do, we can give the service name. Okay. Remember this as well. You can, it is recommended that you have to give the name of the service with the image name. So it will help you. Okay. First, cab driver. It is my service. Then image. We have to mention the image latest. Then container name is this service, cab driver service. So yeah, I haven't given the name, service name here. Same. So you should have the give the in the same name. Okay. Then we have the ports. In the ports, we have to export 81, 80, 81 of my local to the 80, 81 of that container port. So I will bind that port by using this. So this arrow is nothing but the ports is something. If you do in the properties, it will be array. So that's why we have to give the hyphen, and then we have to give like this bind. It contains the special character this. That's why we have given the string. Then we have to give the environment, as I said. Environment variables we can do directly like this. This is 1, this is 2, this is 3, this is 4, like this. Okay. After giving all the environment variable for this container, we can add the depends on here MySQL and Kafka. Okay, it depends on the MySQL and Kafka. It's nothing but the service names. Okay, let's see. First, MySQL here is in a service name and the Kafka here is the service name. So we have to mention the service name here, and after that we have to give the networks app network. So I think I have created the networks. Here we can see networks, then app network, then driver bridge. That's it. So we have created the in the networks. We have to mention the first top level keys. Then we have to mention the name of network here and which driver we will be going to use here. We will be going to use bridge. Then we have created also volumes as a MySQL data. So after that, we will do the same thing with the cab user microservices, almost same thing. Then we also do the MySQL database. Okay, there is one thing I will want to mention here in the URL. You have to mention the service name. Okay, here instead of localhost or anything kind of thing, you have to mention the service name. Okay, here it is MySQL stands for this MySQL so that it will access you know so that it will communicate with this container. Okay, it's enough. I think I have done this. I can do this image as well. So I will give one by one zookeeper and all the remaining properties, subproperties, and networks, and depends on container name, ports, and image. And if you want to build the image from this, we can mention the build key as well here. Then we have the volume set networks. So after that, we can perform the Docker compose up, Docker compose down, Docker compose stop, Docker compose resume, or something like that. And yeah, like this. So you have to mention the Docker compose there as it is a service in the Docker. So depends on wait for start the container, not the internal service to start. Okay. Okay. We have to also give you one hint. I mean warning. Depends on only waits for to start the container, not for the internal service. For example, it will Spring Boot service here. Spring Boot, here cab driver is a service. It will wait for MySQL container, not the application of MySQL to start, in that container. So it won't wait. So for that, you need to queue some advanced things. I don't know what are they, but you can, you know, make the Google or ChatGPT. You will find that. So handle using either actuator here or retrieve properties. Okay. Also, I have given the, you know, it is not the final answer. It is just a temporary actuator and using retrieve properties. Then YML basics, easy notes. Just as I mentioned, first use spaces, not tabs, and use lowercase booleans and put one space after every column. What does it mean? Put one space after every column. Okay, like this here. You have to give the one space after every column. Put then list both are same. List both are same. Okay, you have to give list inline and block style. So as I said, it is an array, or you can set list. So you can give like this as well as like this. Then we have the other strings, chars, nums. So you can mention hello world as like this, as like this, or maybe you can give like this as well. So whenever quotes, if there is a special character, example this, dot, comma, slash, plus, etc., etc. So character, there is nothing terms called characters. You can mention like this as well. Then we have the strings and characters are same here. Age is specified. So whenever you will find a special character, add double or single quotes. That's it. So Docker workflow for Spring Boot, first create a jar. No, first you have to mention okay, first create a jar, then create a Docker file, then build image, run container, and use Docker Compose for multi-services. So here dictionary, I will be going to revise it very fastly. First, Docker Compose, it is a service, then volume, then we have the network to communicate between the containers. Then we have the bridge network, overlay network, port mapping, or you can say that port binding. Then environment variables, entry point, CMD, field context, tag, layer, bind mount, named volume, container logs, restart policy, pull, push, exports, health check, Kubernetes, Docker daemon, Docker client, depends on volumes, networks, container ID and image ID and exec. So by using the exec, it's I think a command we use to access the command line of that any kind of container. Then stop and kill. That's it. Yeah, that was this. I have also added this notes here in the my Git repository. Don't forget to check this. It's very clean and very good notes in the PPT format. Then I also added my notes here, some of the notes. So after end of this video, I will be going to share you one more information, how to deploy an project, Docker project in the AWS. First, obviously build the Docker image. Then ECR is nothing but the Docker registry. We have to upload this Docker image to this registry so that we can build the CI/CD pipeline as well. Then we can use the EKS, Elastic Kubernetes Service. It will be responsible for to manage multiple containers, just like Docker Compose here. As I said, Docker Compose is not the final production version. we have to use the Kubernetes of alternatives for the Docker Compose. Docker Compose is just a beginner friendly. It's not the it does not contain advanced things or major controls. That's it. I think CI/CD pipelines, build a Docker image, push to registry, and deploy with the Kubernetes. Oh, so here also I have weights for not apply inside consistency, portability, lightweight, and that's it. So that was from this video. I think I should have to end this video. Thank you.